Alright guys, so in 6.3 part 5, we are going to be looking into solving for an unknown integral. Very interesting types of problems we're going to see with here, guys. And the goal of this video is to show you a situation in which you end up having the same unknown integral that you basically start off with in the answer itself. And obviously it doesn't make sense how we would arrive at that scenario. And so there's a little bit of manipulation that we have to do in order to actually make the answer in the end make sense. And so we're going to look into how to solve for an integral when we have another unknown integral in the by parts process. So let's take a look real quick at the opportunity that we're going to give here, and some exciting stuff happens with unknown integrals, and it ends up kind of, I don't know, I think it makes it for a little bit more interesting type of integral to solve for than the norm. So let's take a look. The integral is ex times cosine of x times dx. So let's think about limit. Limit would tell us that the first thing that we see in there is our exponentials, right? That comes before our trig functions. So I say we go ahead and focus on making u e to the x, and then we'll go ahead and make d, or dv, excuse me, not du. dv is going to be cosine of x dx. Okay? So now let's just start by what we've been doing every single time, is find du and v right off the bat. We'll find du be the same thing because the derivative of e to the x is just e to the x. Don't forget your dx in there. And then v would be the integral, or the antiderivative of cosine, and of course we know that to be sine. So we have v being sine, du being e to the x, and now it's just, let's go into our actual by parts formula. What you're going to notice, I'm going to really focus on keeping the original in the entire formula the way. So it is true that the integral of e to the x times cosine of x dx is equal to the by parts formula. uv, so let's change some colors here, uv e to the x times sine of x minus, let's change once again, to the integral of v times du. Okay? V times du. Don't forget that dx. Alright? So v times du. Okay. Well, now if you take a look at what's happening here, ex times sine of x, fine. You know, the blue part is taken care of. But you cannot easily take the integral sine x times e to the x. You can try u substitution until the cows come home, and it's not going to really get you very far. So instead, we have another by parts that we're going to have to take into account for our e to the x times sine x dx in there. And so I'm going to go ahead and say, hey, for here, we need to once again make u e to the x, and then dv is going to have to equal sine of x times dx. And so once again, du will equal e to the x dx, and then v, in this case, because we have sine, the antiderivative of sine will give us negative cosine of x. Okay? And so, again, I just want to keep bringing the green down with me the entire time so we don't get lost into what we're actually solving for. And so e to the x, sine of x stays there along with us, and then we have the new red that we just found, because that new red is another integration by parts. So we have u times v, so negative e to the x cosine of x. And then we would have minus the new integral of v times du. So that would be negative cosine of x times e to the x dx. Okay? So we have all of this as being a part of our new integration by parts. And so let's just continue to simplify down. So once again, I want to bring down the green just so we don't forget what the goal and the purpose is the entire way through. And then we have e to the x sine x staying the same. But now notice that we'll simplify this first part here in red, and that will become a positive because negative and negative makes positive, e to the x cosine of x. But then look what happens here. Negative and negative will make positive, so we'll bring that positive on the outside. But look at what we're noticing here. Oh, actually, I'm sorry, that's not going to be positive. That'll be negative because of this negative right in here. Okay? So that will remain negative because of this negative right here. And so that's going to stay negative. So positive, so negative, negative makes positive, times negative makes negative. That's where I'm coming in from here. But then notice what we're about to do. Let's go keep it in red. Notice what's happening here. We are left with the exact same unknown integral in red and in green currently. So think about what's happening here. We have the exact same unknown integral on both sides of the equation. It's actually not a bad thing, because think about what it means. If that was the value of, I don't know, just call it x, or a regular variable, back in algebra, if you wanted to get x by itself, you would combine your like terms. So, what if I went ahead and added the integral on both sides? It would cancel there. I would add the integral over here as well too. And now think about it. I have one of the integrals plus another of the integrals. Well, last time I checked, 1 plus 1 is 2. And so this really just ends up showing us that we have two integrals of e to the x cosine x dx. And that still is equal to our blue part of our right side. E to the x times sine of x plus e to the x cosine x. Well, we're pretty close. We're pretty close to wrapping this thing on up. Remember, we want the value of the integral e to the x cosine of x. Well, the only thing that is causing a problem in here is the 2. Well, this is multiplying. Just like you would in algebra, you would divide by 2, and you would once again divide by 2. Don't forget your constant of integration. And ladies and gentlemen, that will wrap up solving for an unknown integral. So real interesting stuff, if you ask me. Real interesting stuff when we're looking into solving unknown integrals. Really starts adding a little different dimension to our problems here. So I want you to go ahead and give one a shot on your own. Let's take a look. Let's go ahead and look at the integral. So you want to do the same concept. You want to find the integral of e to the x sine x dx, and then I hope that you end up in the end seeing e to the x times the difference of sine x minus sine x minus cosine x all divided by 2. Alright, all divided by 2, and then of course your constant of integration as well. Alright, and again, as I apologize for all the very boxiness of my letters, I'm not really sure what ends up happening here on OneNote. Every time I come in here, sometimes it's not calibrated properly, and it doesn't quite work according to plan, but it does the job in the end. Alright guys, on to the next one.